everyone, welcome to the video. As always, if you like the video, hit the like button. If you want to comment or ask any questions, then please do. If you want to share this video, then please share it with everybody. And best of all, if you want to subscribe to get more great content, then please hit that subscribe button. Now, let's get on with the video. Hi everyone, and welcome to this OSPF DR BDR demonstration. So the topology we're going to be utilizing is shown here on the right hand side. So the routers are VMX running on EVE-NG, and the switches are VQFX that's also running on EVE-NG. So the QFX interfaces will all be on the same VLAN, which in this case is going to be VLAN 100, and this is to create the segment required for the DR-BDR demonstration. During the demonstration, we'll also show complete OSPF commands to explain why the DR and BDR were elected. So let's get on with the configuration. Here we are at the configurations router 1. So let's first of all have a look at router 1's configuration. And we're going to do this as a display set, so it displays the set commands. And as you can see, we have the loopback address, and we have our address that's going to participate in area 0 of OSPF. As can be seen, we also have GE002 as the interface that's going to participate in OSPF, and a loopback address. On router 3, we have GE003 that is going to participate in OSPF, and the loopback address. And on router 4, we have GE004 that is going to participate in OSPF, and we have the loopback address here too. So on router 1, we're going to configure the two basic commands that we need as per the last lesson to get OSPF running, and because we're in a segmented network, we will also see what becomes the DR and the BDR. So we're going to start that configuration work now. So we're in edit mode, and we need to type set protocols OSPF, and our area, which in Juniper is always typed, area 0 is always typed as 4 zeros in IPv4 noted denomination, and we need to put our interface in. Now at this point in time, I need to explain one certain rule within OSPF. For Juniper systems, we can utilize a command that's called priority. So we can actually give a priority to this interface. Now, the higher the priority value, the greater likelihood that the routing device, this particular device, will become the designated router or the DR. Now, by default, routing devices have a priority of 1 to 8. If you put a priority of 0, it's important to note that the routing device becomes ineligible to be a DR. So you may again want to have a look at this priority when you do your OSPF topology planning. A priority of 1 means the routing device has the least chance of becoming a designated router. So if we were to have a look at the command, which is here, it's the priority command, we get a priority of 0 to 255. So if we put a 1, remember, it has the least chance, 255 the highest chance. So let's say we put a priority here and we put it at 200. Okay, which gives it a much more, it doesn't guarantee that it's going to become the designated router, it gives it a much higher probability that it will become the designated router. Now we need to put in our loopback interface. So let's do set protocols OSPF area 0000 interface LO0.0, and we're going to put it in as passive. And now we're going to commit this. On router 2, we're just going to do the basic configuration for OSPF with the two interfaces. We're not actually going to do the priority on the rest of the routers. So if we do a set protocols OSPF area 0000, and we want interfaces on this particular one, interface 2.0. I'm going to use the up arrow now, and we'll go back to the interface word because we want to put in loopback 0.0 and make it passive. And then we'll commit this one. And we're going to do exactly the same on the next two systems. So let's go ahead and do router 3 now. We'll go into edit mode and we'll do set protocols, OSPF area 0000, interface, and this is GE-003.0 on this system. But we also need the loopback on there. So we do LO0.0 and we want to make it passive. And we'll commit this one. And now we'll do router 4, exactly the same, set protocols, OSPF, oh sorry, I've misspelt that, protocols, OSPF, and we're going to put the area 0000, interface GE-00, I think it's 4, yes, 4.0 on this system, and we're going to put the loopback in as passive. So LO0.0 passive, and we are going to commit this one. So we're back on router 1. I've used the exit command to go back to operational mode from configuration mode. So the first thing to do is let's have a look at the neighbors. Show OSPF neighbors. Now we can use extensive detailed commands, but we're just going to do the basic one for the moment because I want to explain something. So here we see the full on all our neighbors. Now do you remember that we said that a neighborship will only be formed with a DR or a BDR. Okay, you won't see that between DR others, which are other routers in the network that are not neighbors to each other, because in this particular type of network, segmented network, you're only going to get a full relationship with a DR or BDR. So the fact that this says full on the other three suggests that this is either a DR or BDR, and we'll look at router 2 to see what we have here. So we do a show OSPF neighbor, and we have full here as well, which means it's either a DR or a BDR, which means these two should have two-way relationships to each other. So if we do a show OSPF neighbor, and sure enough, we have a two-way relationship to .13.123 loopback, which is router 4. And if we go on to router 4 and have a look, we'll see the same for router 3. But we'll have a full relationship with routers 1 and 2. So let's have a look at routers 1 and 2 and see which one is which. So we'll go to router 1, and to see this, we go to show OSPF interface will tell us this information, and straight away the state is a DR, and the DR ID is its local loopback address, and the BDR's loopback address. The DR other is for loopback 00 because we entered it as passive. If we have a look at router 2, show OSPF interface, and we see that the state is a BDR, and the DR is 120, it's router 1, and the BDR is itself. If we go to router 3, show OSPF interface, it sees itself as a DR other, which it is, okay, because it's not a DR or a BDR, so it's DR other, but it also shows you the same information. Okay, we could go into an extensive and have a look at it from that perspective, and that tells you the information as well. So it shows you it's a DR other, it tells you the DR, BDR, it gives you its addressing, it gives you its cost of the interface, It gives you all the information that you need here within the extensive. This is loopback 00, so you're not going to see a lot on here anyway. Okay, and that'll be the same with the other systems, including the DR. So if we do an extensive here, and we see exactly the same information. So what happens if we shut down the interface here that's participating in OSPF to make it the DR? Well, let's go ahead and do that and see what the results are. So we do a set interfaces GE-001.0 and we disable it. We commit this and we are going to go to the other routers and see what the results are. So we'll start by having a look at router 4. Now, previous to us shutting down, disabling the interface to replicate a failure of the DR, we had this. We had full, and two-way. So let's see what we have now that the convergence has completed. So if we do the up arrow, let's see what we have now. Now we have a full, and that's because we only have 3 systems, but we need to do a show OSPF interface. So now this system has become the backup router, the backup designated router. The designated router has become 121 from 120. That will be router 2. So let's go to router 2 and just confirm this. So again, we'll use the up arrow. Now, as can be seen, initially the DR was router 1, but we have replicated a failure of that system, and the BDR was 121, but the BDR has been promoted to the DR, and 123 has become the BDR. We're now back on router 1, and I have re-enabled the interface that participates in OSPF. And you'll notice that the DR and the BDR have not changed. And this is on purpose because of the convergence times, and they would not want you doing this on a live network. So this is the reason that this particular system has not become the DR again. So before we conclude this tutorial demonstration, let's just have a quick recap on the priority command. So the priority command is configured under the protocol's OSPF stanza, as we can see in the following example I show you now. So we do a set protocols OSPF area, the area you require. In this case, I've noted the backbone 0 area, interface and the interface that you want the priority configured on, and it can be anywhere between 0 to 255. Obviously, the higher the priority, the greater likelihood the routing device will become the designated router, the DR. Okay, by default, routing devices have a priority of 128. This is if you don't set a priority. A priority of 0 marks the router as ineligible to become the DR. In other words, it cannot become the DR. And a priority of 1 means the router has the least chance of becoming the DR. So that concludes this DR BDR demonstration. If you do have any questions regarding any of this or any other questions on DR BDR election processes, then please let me know. Hope you enjoyed this video, and please don't forget to hit that subscribe button, because we're going to be doing some more demonstrations on different areas, and we'll be looking at the LSAs involved in those areas. Thanks for listening. Take care. Bye-bye.